Hello and welcome to another episode of GothamSound.tv. I am very excited to be here with Anton Shmakov. Hi, Anton.
Hello, Peter.
Very good to see you in the studio. For those that don't know, Anton is CEO and founder of MR Nett, which is a company that makes mobile broadband routers. It's a product and a service. So I think probably the first thing that we should say is, who is this video for? I think this video is for anybody interested in connecting a remote event, including film production, or some kind of live event, or some kind of event that has a gathering of people where you need to connect that event to the internet. Specifically, events that don't necessarily have standard hardwired internet connections. So I think if you are, for example, a sound person, which is very typical of our audience, we will not be discussing sound equipment. So I just want to make sure that we've sort of framed the conversation so that people know exactly who this is for. So we want to talk about connecting remote events to the internet.
That's right.
Now, I had described how I was going to introduce this video earlier, and I said, so that way if there's any sound people watching, they're going to tune out. And you said, well, wait a minute, maybe sound people want to see that. And I said, hold that thought.
Yep.
So tell us, let's start with why would a sound person, or by extension, a camera person or a crew person, want to see this video?
Admittedly, we don't have too many sound people as customers, but we have a few, and I believe we should have more. Because, for example, I think the most notable use case we had with sound people specifically were remote team comms at big events. Like, we had a company who were doing a lot of MLS games last season.
Okay.
And they had remote internal comms, and they had some people on site and some people obviously in the studio, wherever.
Sure.
And they needed to communicate with each other, and they were using us as a gateway to make a reliable pipe to connect all the comms together without relying on any local infrastructure, because infrastructure was there for the main broadcast. It was high budget productions, but for them to plug into those networks was too much of a headache, and they just had this independent unit which were running the network for them, providing them all the coverage they need, so they don't need to think about it again. They just was part of the rack. They were wherever they were going, they knew the comms were going to be working, and that was very beneficial for them.
Got it. So it's an option that allows somebody to bypass or create their own connectivity. So let's start with, what is the MRNet product and service?
And service, yes. And so it's actually, we can dovetail to what we were talking earlier about what the use case is, because ultimately, yes, we provide reliable internet connectivity wherever you need it, and we can just stop the pitch here, because that's ultimately what we're trying to achieve, is that, as our motto says, simple, unbreakable wireless, and that we're trying to live by it. So we having the product attached with the service, and we're including everything into it which is necessary to keep it simple and truly plug and play. So even non-technical person can boot it up in seconds, and it's just gonna work, and they don't need to worry about it. That's it.
And it looks like a router.
We prefer the gateway name, not the router, because there is a difference in terms of routers do a lot on the local network. We intentionally don't want to do a lot on the local network, because there are dozens upon dozens of different brands who are doing local network extremely well, and there is really no value for us to add there. So we focusing on what we do best, and where there is a gap in the market, which is the last mile, which is connecting to the internet, which typically referred as gateway. While we do have routing capabilities, we really don't. If you need any advanced local network, we say just put your local router next to us and manage your local network yourself. We can dive deeper into it why, but that's going to give you much better results over time and much more consistency. It's just better on so many different levels.
I can completely see that. And so my understanding then is if you wanted things like multiple Wi-Fi access points, if you wanted some kind of sophisticated VLAN settings and different sub-networks.
Or local firewalls or whatever else you might
And
be.
firewalls, then you'd get a separate router.
Yep.
But in a typical router's sort of configuration, they would have a WAN port, and that WAN port would plug into the LAN port of your gateway.
That's exactly right.
Okay. Got it. That makes sense to me.
So, we will talk more about it. Coming back to the simple unbreakable wireless piece. So we're making it simple by, we have this advantage, what I call it trifecta of expertise, which I think is unique on the market and which allows us to deliver on our promises, which is we have product understanding and expertise, we have services expertise, and what everybody else is missing is a telecom expertise built into it. So as a result, while we do provide hardware, we think of hardware as a very utilitarian tool just to deliver the service as a vehicle for the service.
I think a lot of people hear what you're saying and they say, oh, well, my phone can be a hotspot.
Yes.
I can tether my phone, or I could go to my carrier and get a hotspot. So let's sort of break it down. We are talking about a device that works over cellular networks, but how does it differ from a hotspot, for example?
Yeah, so that's where we transition to the uninterrupted part, unbreakable part. Like, why is it unbreakable? Because in our case, it is unbreakable because it has triple cellular modems inside. So there's 3 individual modems. Each of them connects into 3 individual networks. In US, it's going to be Verizon, AT&T, and T-Mobile. I personally spent years figuring out, procuring the right data plans, working with, I think we worked with 20 different data providers at least, and we found the one which is really exceptional at what they do. And the way the data, like not all data is created equal, which was even a surprise for me when I was digging into it, not to mention for the average person who just knows it's just data is data. Because the way it's routed from tower to tower, from node to actual internet, if you actually break down those pathways, you will see there is a lot of different things happening between you and actual endpoint.
Let's dive deep into this, please.
Well, so there is also the side of the priority on the network. So you know that there is multiple consumer plans. There's like MVNO plans. There's direct consumer plans.
For those that don't know, MVNO.
Oh, yes. So it's basically, well, you know the top 3 carriers, but there is a lot of other sub-brands, like the branded plans.
So for example, me on my personal plan, I'm direct with Verizon.
Okay, so
Right.
yes. So this is your one level above what would be MVNO on Verizon. A few years ago, they finally opened the network to MVNO, so there's a couple other.
And what does that stand for? Do you know?
Mobile virtual network operator.
So MVNO is the next level down.
So this is going to be, typically, it's going to be the lowest priority queue. So if you show up at a stadium, there's 50,000 people. If you're on MVNO plan, your data going to be slowed down the first in line to go shut off. Then it's going to be direct consumer lines, which they will try to keep as long as possible. Above them, there is enterprise subnets. Typically, it's like there's different carriers handle it differently. The easiest way to bolt them together is enterprise IoT subnets, which goes above the consumer lines. And those, what the priority means is that on the tower itself, your data not going to be throttled, not going to be capped, and it's going to go through first in line. However, there's still a problem to get to the tower, because you're going to use the same frequencies, and if you have so many people, it's going to be a bunch of interference. So there is no silver bullet for that. There is a first responders networks,
Right.
which has separate bands, specifically band 14 in US, which is designed for first responders, and it's actually available to the public, but in case of an emergency, they kick public out and keep it for the first responders. At least that's how it's supposed to operate.
Right.
So that's how they manage the physical layer. But on the regular networks, you don't really have so much band segregation as much as just stacking up on the cells within the tower itself and making sure that the tower going to prioritize your enterprise data first.
So I think for those of us keeping score at home, We can think of this as multiple layers. There's multiple, let's call it quality of service that the carriers offer. So they offer the highest quality of service, it sounds like, to public safety, public safety enterprise, direct, and then MVNO, which are the kind of prepaid, like Mint is an MVNO.
Exactly,
right.
yes, which is home 5G internet. So this one is below consumer. So meaning, so if you, when they overestimated capacity in some neighborhoods, you could see that like at the home, at peak, rush hours for the internet.
Which is like everybody watching Netflix
exactly,
at 8
exactly.
o'clock.
Everybody goes home like 6, 8 p.m. Everybody's watching Netflix, YouTube, and you have like multiple people on multiple devices. And what you will see is that your home internet is going to slow down, but your phone's still going to be working fine, because that's what is more important to the carriers, at least today. So, but it's only for 5G, so it doesn't really matter for the 4G deployments, difference between 4G and 5G, we will dig into a little bit more, because it's actually a very important conversation.
I would love to have that conversation. And this conversation is based on, we both have experience with getting data connectivity to remote-ish places. Even if it's not remote, it can be a challenge. And everything you've said to me so far has resonated, including the 5G, 4G conversation, which we'll have in a minute. I want to keep sort of the bigger picture in mind for people. So that there's all these different levels of quality of service, and we've talked about the RF layer, which all of these different quality of service ride on the RF physical layer. Then, once our signals get to the tower has to have enough capacity to handle all of this traffic. So even assuming that the RF layer has all the capacity in the world, the tower has to prioritize traffic back to a main hub, main switch. And that's technically called backhaul, the backhaul from the tower to the next line link in the chain.
Yes.
And that's, correct me if I'm wrong, but that's where the gateway, the router in the tower, starts to drop and prioritize traffic. So if public safety is involved, it'll drop everybody else.
We can get,
I mean, these
if you get too much into the weeds, we'll definitely get it wrong, because again, it's going to be different for different carriers, for different towers, different networks, different regions.
But no, there's carrier-grade infrastructure at the tower, and it's got to make decisions about how to prioritize traffic.
Yes. Okay. It's not the most public information. It's not a secret, but it's also like not really discussed much. And so it's the exact implementations again. Like even if you talk to the carriers, they will not always give you straight answers there.
Gotham has been in the data sort of providing cellular routers since the very first cellular router, which was started by a couple of Sprint executives called Junction. It was a green box, and it used PCMCIA cards. That's how old it was. And I can remember trying to have conversations with the carriers. You know, the first level is you go into the store, right? And you say, hi, we rent data, and never mind that that's a violation of terms of service, but they treat you like a consumer. Then you've made it to the level of being a business, and it's been all this time. I mean, it's got to be 20 years at this point, where finally we hear the word enterprise from the customer service reps. Oh, you need an enterprise rep to deal with. And that was at our peak, pandemic, we were doing 1 terabyte a month of data, which is not insubstantial. And even then, we couldn't get them to say that word enterprise. So when you say this has been, a journey that's taken decades, I'm right with you, brother.
Well, so that's coming back to the simple part of it, because if you're trying to procure data yourself, just to get a data SIM can be not an insignificant challenge, and then to manage it and then figure out which one is right. And with us, that's why it's part of the service, is because with us, it's already included. The only thing you need to do is turn it on.
Right. And I still want to make sure we really contextualize all of this. So I go out and I get my hotspot. Let's say I'm working on a production comes to me and they say they're doing camera to cloud. I say, great, I'm going to go get a hotspot. I'm going to make a rental on this. And I'm not suggesting that you shouldn't do this. If you want to do this, send me an email. We'll talk about it. But the first thing you'll notice is there's no such thing as truly unlimited when you go to a carrier.
Yes.
So that's the first thing. And so talk about what that means. That, you know, they say unlimited, but what happens when you reach a certain
Well,
point?
there are a lot of different fine prints. Again, it's going to be different carrier to carrier. It's going to be different 4G versus 5G. And it's going to be different consumer, enterprise, or MVNO, whatever there is so many different permutations of this. But ultimately, the average case would be they're going to say unlimited, and the fine print going to say you have 50 gigabytes of fast speed data, and everything below that, they quote unquote may slow you down, which doesn't mean anything, because if you're going to be in the area where you don't compete for the tower, you're still going to be fast and first, and it's going to be fine. But if you're going to end up in those places, as we discussed, where there is overload, they're going to have a dynamic billing pop up, and they will see you already used 70 gigs this month, and so in this congested area, we're going to slow you down to 128 kilobytes a second.
Right.
And that's where you're just stuck with it. They're not going to get above you,
I-
which is not enough for anything.
Even early dial-up was 1,200 kilobits per second.
Exactly.
So it gets rough quickly. The other thing I think we should talk about in terms of contextualizing this conversation is the carriers assume that you are a consumer of data, right? So they're going to prioritize the download speeds.
Yes.
And a lot of our use case scenarios that we deal with is upload.
That's
and
right.
So that's another issue, and that affects both the physical layer and the quality of service.
Exactly. So that's just trying to weave all these threads together, because we now have a couple loose ends left.
Yes.
But as far as yes, absolutely, that's if you use your phone and you have perfect latest 5G phone or old 4G, doesn't really matter. All of them are very asynchronous, and the way the antenna design is, the way the modem design is, the way the carrier bands are operating, is that you have roughly split 5 to 1. 5 for download, 1 for upload. It's like, again, rough distribution, meaning because regular consumer, they care about download, they really don't do much upload. And
Right. You make a
fine.
request to a website and you get a
Yeah,
whole
get the
torrent
actual
of
data. Exactly.
Yeah.
So that's where you're absolutely right. As far as a commercial product, we need to be very conscious about that. We making sure that we are not optimizing for the average scenario, because that's not what average for our customers, for whom uploads tend to be way more important than download.
And now I think we're slowly transitioning into the service of MRNet.
Yes.
Right? Because, okay, we've convinced our viewer that the hotspot is not good enough. You can go on Amazon and you can find lots of off-brand, multi-radio, well, let's just say wrongly multi-SIM cellular routers. Even if you find multiple cellular radio routers, you can find all of that stuff on Amazon. And to be fair, we sell the Peplink products, which do that.
I wouldn't lump the Amazon products with Peplinks, because it's actually different categories.
Fair.
There's a lot of consumer grade individual, like single SIMs or multiple SIMs, single modem or multiple modems. And then the Peplink is they gear towards more enterprise, more complex solutions.
Correct.
So there is a gap in between.
So even if you go out and get multiple SIMs, and we've seen news crews, it's amazing. They have 8 wallets of 8 SIMs when they cover an event, right? So even if you did that, there's still a gap that's needed. And so let's talk about the service of MRNet.
Absolutely. None of those solutions, let's not talk about Peplink for a second,
Sure.
but all the quote-unquote hotspots on Amazon,
Fair.
none of them have real aggregation. So the best you may find is load balancing, which means you're going to spend a few weeks figuring out how to configure it, and eventually we'll say, this stream of data going to go over this SIM, and this stream of data going to go over this SIM. And if any fluctuations happens, good luck you on your own.
So this is a great dovetail into this, because we constantly get requests for bonded cellular modems. And I think very, very few people who ask for bonded cellular modems really know what's involved.
Yes.
I think let's talk about the difference between a cellular router that has 2 or more cellular modems versus truly bonding them.
Well, so this is going to be on the data layer, on the firmware, and that's you're right about the service piece, is that the load balancing means you have multiple different WANs, wide area network access points, and in this case, it's just cellular access points. And they can be either used as a failover chain, meaning this one failed, switch to this one failed, switch to next one, etc. Or with a load balance scenario, meaning you have data overall, let's say you're using 20 megabits, and one of them, 10 megabits is going for your stream, 5 megabits goes for your comms, and another 5, I don't know, for the general purpose email, stuff like that, as an example.
Right.
And so you will program that this stream gonna go over this channel, this stream gonna go in another channel, and that's how it's quote unquote load balanced. But it's very naturally, there are two big problems with this. On the user side, it can get very complicated very quickly. Because for you to understand which data gonna go where, and then you'll find out that you put one IP but not the other, and everything falls apart. And you just so many ways to shoot yourself in the foot.
I mean, one of the ways that it gets complicated is when somebody has an issue. And now, how do you know which issue they have?
Exactly. It's just, let's table it's not an ideal approach. And on the quality of service issue is that because especially in cellular world, and that's why nobody likes cellular, because it's predictably unpredictable.
Correct.
Predictably unstable, and it's not only unstable place to place, even in one location, it's going to be unstable moment to moment. And it's going to give you one performance, and it's like most commonly recognizable pattern. You show up at an event a day ahead of you, a day ahead of the event, you set everything up, everything works perfectly, you show up the day of the event, and everything just doesn't work anymore. Reason being, as we discussed, there is loads and overloads and interference and a lot of different things. But basically, coming back to the idea, if you rely on any stream of data on a single cellular pipe, you're setting yourself up for failure inevitably. Whether it's going to happen right away, whether it's going to happen once in a while, it's going to depend on your style of deployments. But failure is inevitable in this case. It's just a question of how often and how bad.
And this is the nature of cellular specifically and wireless wide area network.
I would say
general.
You can extrapolate to any infrastructure in general. Doesn't even have to be internet, because if you rely on a single pipe for anything, it's destined to fail. The question is what the nines of probability it's going to happen. And with cellular, the nines are shorter than for the rest, so that means it's going to happen more likely, and that's why it's more relevant there. And that's why the concept of bonding comes into play, is when you're not pick and choosing, you're not trying to figure out which one is the best in this given moment and ride on it, and then somehow be smart about how to switch. It's about using all available sources at the same time to their best capacities at all times. And this way, if you have any fluctuations, the data gonna dynamically spread around. And I think like it's worth like small metaphor how bonding actually works in our case. So I like my cat metaphor. Like if you need to send a picture of a cat across the internet, normally it would just be you package your cat, you probably encrypt it, you send it to the carrier, and carrier delivers your cat, and then your receiver side, whoever we send it to, decrypts it and they see the cat. What we do is you send a picture of the cat, you encrypt it yourself, it lands to our gateway. On our gateway, we splice this cat. So in our case, we have typically, by default, we have 3 channels, 3 cellular. So let's say it didn't connect anything else, so we have 3 channels. So we're going to splice the cat and we say, there is head, there is body, there is a tail. We're going to re-encrypt those chunks again, so second degree encryption, and then we're going to send the head over one channel, the body over the second channel, the tail over the third channel. Then it's going to land on our server side, so which means we took care of the most unstable piece of the networking, which is coming from your device to the intranet, which means it needs to come to the tower and from the tower to the intranet. So this is the most unstable piece of the network. It lands on the server side, which has good dedicated fiber run by the best server providers in the world. And there it gets, those individual chunks get decrypted, and your cat gets reassembled to your original state, which is your original encrypted cat. And then we just send it to the web, and your receiver just gets the same exact package as they were expecting before, not knowing that in between it has this detour of splicing and reconstructing, which naturally improves the performance bandwidth-wise. It improves the security because now man in the middle is becoming much less likely, much harder to execute. And also, it gave us so much more reliability because if you're not sending a single cat, if you have a herd of cats you want to send pictures over, and you have hundreds and hundreds line them up, what you will see is that sometimes one of the channels is going to start choking, and then what we're going to do is we're going to start pushing less data over this channel, and we're going to push a little bit more data over the other channels, and it's going to happen dynamically.
So what I hear you saying is there's a bonding going on at the gateway, which is the customer side of the equation.
Yes.
And then there's debonding going on in a dedicated server environment with high quality internet connection.
Exactly. And so if somebody who listens, they are familiar with some systems, what's often they expect is that they have to manage the debonding side. Sometimes you have to purchase a separate piece of equipment to have a debonded solution, a decoding solution. Sometimes it's just something you have to manage yourself, which is complicated. With us, the way it's architecturally set up is that you need to do nothing. You just plug it in, takes 30 minutes to turn it on, you're done. It's just gonna work. And the way our server side gonna look on your side is you're just gonna have a different public IP, which side effect benefit, now you're going to have consistent public IP across all your connections, which means if you have any sort of remote production flow, now you don't need to think about, I need a dedicated IP from this carrier or from this venue. And then how do you reconnect and readjust and reconfigure everything when I move places? Now you're going to have the same exact networking setup wherever you go. And what we haven't talked about is that we can receive additional sources of internet. So while we have built-in 3 cellular, and we swear by that it's going to be the best seller on the market because we've done our work finding the best partners doing deep integrations. Real quick side story on deep integrations is like I've been not at war, but I've been really asking one of the big carriers to fix one of their enterprise subnets because one of the protocols we rely on, they just wouldn't support on the enterprise subnets. And what it meant is that we had to go at length to introduce additional wrappers, which made the data just a little bit slower. So it was, from the customer perspective, nobody were ever noticing it.
It just isn't elegant, it sounds like.
But it wasn't elegant, and it was not perfect. And we were just trying to resolve it for 3 years. We were in different ways of conversation. We had direct, we had through the partners. Long story short, a few months ago, we finally got our way. They finally patched our subnet we are running on. And now the protocols we use support it natively, which means that on this specific carrier, our data is about 10-15% faster than it used to be.
Wow.
So as a result, overall product, again, became stable, more elegant, faster. And good luck finding another partner who's going to do it for you.
Well, that's the other thing is to for individuals to do this, even for us to do this work, it's virtually impossible. I mean, we have a connection to somebody that used to work at a carrier.
Yeah.
And even them, like they're very limited in what they are willing to do. I doubt they would even entertain a conversation like that.
It's not the conversation anybody who, if you would spend a few $100 million with them, they would talk to you.
Right.
We are not spending that much, so we had to find a bunch of other levers how to pull it off. But anyway, coming back to what we were talking about, so that we swear by our cellular that is going to be the best of the best on the market, but we can receive additional sources of internet, whether it's your local venue internet, whether it's a hotspot you bought on Amazon and you just have much cheaper data there. Plug it in, we're going to use the hell out of it. And if it's working, it's going to work great. But if it's not going to be slowing down or if it's choking, we're going to supplement it with our data.
And by the way, this is another advantage to having the debonding pair, because the debonding server can inform the gateway device, some connections aren't working so well. And there can be a two-way conversation between them.
Exactly.
Yeah. So that's a huge part of it. Another WAN use case scenario, in addition to the 3 cellular, is Starlink.
Yeah, very common.
And so I think, we have customers, despite our best advice, that only stream on a single Starlink. And I would never do that. I would never do that for a birthday party I was trying to stream, let alone a professional event. But, if you have a solution like MRNet, then it's just going to use Starlink when it's up, and 1% that you get cloud cover or whatever, it'll switch.
Well, that's we have actually quite a few customers who are using both, and that's exactly the promise. Is that Starlink is extremely good at providing connectivity where there is none, and they're definitely best in the market for that. But there are gaps, which is inevitable. And coming back to the idea, like our whole philosophy is ultimately any type of infrastructure, if you have a single pipe, it's going to let you down. And our approach is we don't really care what kind of pipes you're going to use, whether it's going to be a physical wired internet, whether it's going to be a satellite internet, whether it's going to be cellular, whether it's going to be some new method of connectivity emerging. As long as it can send bytes from you to the internet, we can use it, we can plug it in, and now we can aggregate it with everything else. So we have seamless improvement of performance, but first and foremost, what we focus on is the reliability piece, because there is one penalty we have is we reducing peak performance, because peak performance in our experience is not something relevant for actual majority of actual business case scenarios. What peak performance means is top speeds.
So this is a common thing that we experience where we'll set up a bonding server or through MRNet, and the first thing a customer does is run speed test on it. And they say, oh, I could get higher speeds on a single connection.
Yeah.
And our typical answer is that's not the point. That's not why we're bonding.
So there's two answers to this. First of all, absolutely right, that's not the point. Second piece of it, it's actually, if you look on the upload speeds, majority of the time we are all going to outperform anyway,
right,
even though it's not the point. And the third piece is specifically most common. They pull out the latest iPhone on the good 5G, and they have 5 bars on the 5G, and you can get up to gigabit down on a good 5G connection, which is, this is a new unit, and this is going to be capped at around 250 download. Mm-hmm. So we're never going to compete on peak download speeds with an iPhone, but go show up at the conference and see how it plays out for you.
Right. If
you're going to try run your event on that iPhone, because sometimes it will, many times it won't.
That's right.
And especially for the uploads. And we've seen it so many times when we in the middle of a trade show or a conference or live event, big or small, doesn't really matter. And when people pull up their phones and it cannot open LinkedIn, we cannot really exchange accounts. It just chokes, not to mention videos. And people connect to our Wi-Fi, and now they can show their 4K demos to us so we can enjoy what they have to offer. Because it's different type of data, different type of use case. And just because it works sometimes doesn't mean it's going to work for you all the time with your regular single source connection. But what we promise is you're going to receive this reliable, predictable baseline. Now you can build your workflows around. And that's coming back to the idea of the peak performance versus the baseline performance. Mm-hmm. What I always say is that we are the best solution for the worst case scenario. And that's what we optimize for. Because ultimately, if you're trying to scale any sort of operation, what matters is what is the baseline you can build upon. And if you're going to show up in a perfect location and you do get gigabit speeds, great. Are you going to build your workflow around gigabit speeds? I would say if you do, and you're trying to rely on any sort of wireless for this, you're setting yourself up to a big disappointment.
Let's take point of sale as an example, right?
Yeah.
These festivals, these events, they have point of sale kiosks. Point of sale is not about big data.
It's about
throughput.
Delivering.
That's right. And if you can't get that point of sale data through, that's about lost revenue.
That's right.
And so I think, if nothing else, you can think of MRNet as a solution for even low throughput applications like point of sale. And also it's suitable for those of us streaming video.
Well, so now we kind of tiptoeing our way into the common streaming applications, which we have a lot of customers doing. And I would say right now, as a company, we put a lot of focus on live events specifically, mm-hmm. and live event sub-segment, which requires quite a bit of video and video streaming. And what we see, as we're talking about the reliable baseline, we've done probably tens of thousands of events by now, or rather deployments with customers, because we never there. Like all our service is delivered remotely, and part of the service, which makes it simple, is that we have broadcast-trained networking engineer on call after hours at all times. So if you have any issues come up, you ping us after hours on Saturday afternoon. We're going to respond within a minute, and we're going to figure out with you what's going on.
And so even though the gateway itself is protocol agnostic, if you ping one of your engineers and start talking RTMP or SRT, they'll have a sense of...
They will So that's kind of, you kind of highlighting the issue with our service, sort of say, from operationally, is that we are general purpose internet. We are not a media device.
Right.
You just plug it in, whatever requires internet is going to work.
Right.
And there is a long tail of edge case integrations, which is going to be, it's basically physically unresolvable. It's infinite amount long tail, but we can say that 99.9% is going to work out of the box. But even though we provide general internet, and now we have such a high degree of confidence that our stuff just works, at this point, it just works. But people come to us when something doesn't work and say something is not working, and there's two reasons. First reason is it's always easy to blame the network, and that's kind of like default mode of any technical person. If something is not connecting, it's a network issue. Most of the time it is not, but that's going to be the first.
Same with RF, by the way.
Yeah. And the second problem is we are the only people who actually respond.
Well, so that's what I'm getting at. In other words, and this gets to the point of why you have 3 different cellular carriers within your gateway. The first, off the top of my head, 3 different cellular carriers are licensed in the United States, generally for 3 different sets of frequencies that they pay. They
share some bands, they share some unique ones, but yes.
But overall, right out of the box, it's likely I'll get 3 separate paths, even if it's to the same tower. And we still can't control the tower, backhaul inefficiencies. And that's where something like a Starlink or a hardwired WAN connection comes into play.
Yeah.
But at least that first physical layer of RF, I am likely on 3 different paths. When somebody calls to one of your engineers, how much insight do they have to my gateway on site?
Well, so they can see what's going on. So we we take privacy and security seriously in terms of we don't have any data stored. We don't know what you're actually using with it unless you explicitly come to us and say, please track my data because I don't know where it's going.
Sure.
Then we'll figure out how to set up some trackers and see destination points. But typically, we cannot tell you what you've been doing, but what we can tell is that, okay, the signals is this way, the data throughputs are this way, this carrier is a little bit better than the other, and we see that you're trying to push X amount of data through the gateway, and so that's rough idea. Like for example, the actual typical support requests, I would say one most common is they come to us saying something is not working. We look up all the diagnostics and we see that our unit performs very, very well. There is nothing needs to be done. It's giving you more speed than you need. It's very stable. There is nothing going on. And then we just explicitly tell network is fine. Something wrong is on your setup. And then hopefully they will start digging themselves. A lot of time they come to us like, what am I doing wrong? Because again, we are the only people who reply. And then we do the diagnostics on somebody else's products as part of the service, which again, we shouldn't do, but we help out, and it's been a big help for our customers.
I completely get it, and we're often in the same predicament with our customers, where a lot of times it's an issue on the local side of the network, but we're helpful people. And the ability to remote in is huge, right?
Yes.
I mean, sometimes it's as simple as, I see an antenna isn't connected properly.
Yeah, exactly.
Do you ever go in and start to block off certain bands?
So it's very, very unique scenario where similar to infinite edge case on the integration side, with cellular, there is pretty much infinite edge case of how you're going to handle the bands. And our algorithms got very good at being smart about most of them, but there are going to be situations where it's just best for everybody to just shut off one of the carriers because they like very slow, very unstable, but fluctuating, and like 1 second it give you a megabit, and like megabit is good enough, I can use it, and next second it's complete zero, and the next second it gives you megabit, but it has like 500 millisecond ping, and it's keeps bouncing around.
This is a perfect segue into talking about 5G and why it's not always appropriate for streaming.
Yes. So 5G, 4G. This unit is going to be our flagship, and it is 4G exclusive. We are working, and we're likely going to have a 5G unit at some future, but the use case we're going to position it for is going to be different. For the streaming live events crowd, I will still very, very, very strongly suggest that you should run on 4G exclusively. And the reason being, and the reason being is that 5G, while on the technical pamphlets marketing, they will tell you that if 5G is not available, it's going to backdrop to 4G, and it does. And you can see your phone does it sometimes, and it does. The problem is the cutoff, is that 5G can be slow but working, and 4G can be faster, but your automation, your tower will never switch you back to 4G, because what they optimize is 5G loads, and especially on upload speeds, what we've seen consistently over especially last year, I think it's where it became its most notorious, is that there are much more and more load of data being shifted to 5G, which is great, and download overall seems to be doing relatively fine on 5G. Upload, because there's so many more devices, upload started suffering, and upload on 5G consistently slower than what we see on 4G in those extreme environments. And again, in best case scenario, 5G gonna be
right. If you're the only one in a field with 5G,
it definitely gonna be. You're gonna smoke 4G, and again, if you have a perfect 5G setup, you're gonna smoke our bonded triple 4G.
Yeah,
I'm fine with that. But when you go to the overloaded environments, what you will find is that 5G upload performance is very often slower than what you would expect, and 4G is actually giving you this predictable performance baseline. And then we can talk about the propagation questions, is that 4G is 5G is kind of like cumulative term. There's actually a lot built into it, and there is portion of it is actual different frequencies. And you probably heard microwave sagas, which now pretty much everybody discontinued, because turns out building a tower on every single intersection is not feasible.
Yes.
And then, but there's also long range, and there's what they call C-band. It's probably the most common 5G which stuck around, which is new medium, new RF, which gives you the performance, but they kind of found the balance between delivery, meaning the distance and propagation, and the quality of the data, amount of data they can push through. But another piece of 5G is heterogeneous side of the network. And that's actually like not very... It reminds me when I was at your event a few months ago, and you were talking about how some of the protocols almost chalked off some of the RF for the audio. I don't remember the details, but there was some saga about somebody almost took over the spectrum.
T-Mobile bought a bunch of 600 megahertz spectrum at auction, and to be fair, so did a lot of other carriers, but T-Mobile got the bulk of it, and so they had to work to really get a lot of wireless mic users aware that there was going to be interference.
What happened in 5G space, in 5G saga, is that originally when it was proposed, there was very aggressive use of Wi-Fi spectrum. And what almost happened is that if you would have a 5G tower in your neighborhood, your home Wi-Fi would just completely be dead. And they were negotiating it. It was, again, completely under wraps. Not many people heard of it, except people who actually been involved. And then what ended up being is that 5G still using a lot of Wi-Fi spectrum, but they made the clocking way, way less aggressive against the home Wi-Fis. So now they share the same network. They share the
And
same
are we
spectrum.
talking 2.4 gig or 5.8?
Both, but primarily 5.55
Okay.
range.
Uh-huh.
And in the 5 range, they were very aggressively using this line, and then because of the over negotiations, the clocking started again much less aggressive, and now Wi-Fi is fine and it can like exist. But it was dangerously close because industry was pushing to like being very, very aggressive using 5 gigahertz spectrum for which used by Wi-Fi. But ultimately, what I was trying to say is that the 5G second part of 5G is heterogeneous networks. So under the hood, under the design of the network, they're supposed to be using some of the 4G technologies as part of the 5G connection. In practice, again, the way it's distributed, the way it's deployed, the way it's optimized, at least today, the reality of 5G on the field is that you're not going to get as consistent results, you're not going to get as consistent propagation, as consistent availability, and in extreme environments, you're going to get typically worse upload than you would get on 4G, and that's why what our goal is to not give you the fastest possible speeds, but to give you enough performance to be able to deploy in those live streaming environments. Basically, our core offering is that we can practically guarantee that wherever you go, you will be able to pipe a single stream out. And if you can do that, you can do a lot. And that's ultimately what we promise. You can potentially say, I want to have 4 streams. I can want to have 6 streams. And sometimes it's going to work, and sometimes it will not. And you have to have your degradation strategy, which streams you're going to cut off, how you're going to reduce your rates, all of that. But if you build your deployments around the fact that one stream going to get out, and if you want to have multicam stream, and that's kind of be dovetailing into the idea of what I believe this unit will enable quite a bit, is a lot of remote deployments for the live streaming, especially like if you pair it with several PTZs and some version of the local encoder, which you're going to pick and choose which stream actually going to be piped, and there's so many ways to solve it. It's either going to be independent encoder on site, or now quite a few PTZs started introducing local routing, where they have NDI bridge and NDI router on the camera itself.
Yes.
And then this single camera can become a master camera. And if you have like 3 or 4 different PTZs shooting independently together, all of them can have a kind of administrative feed. So you can manipulate them remotely and you can move them around. But those don't have to be high fidelity. Those can be like 200, 500 kilobits is more than enough for you to understand what's going on, to understand where you need to point it, to do everything you need to do. And the only one stream going to be prioritized at full capacity, at full quality coming out. And this way, you can have a 4-camera, multicam, professional looking shoot for an event, which is going to stay under 10 megabits consistent upload.
Right.
What makes it, you connect it to this, and now you can ship it out anywhere in the country, and you know if you provide power, it's going to work just fine. And so all of a sudden, instead of sending the crew everywhere, now you can send in the remote kits everywhere, and they're just going to work.
Right. And because it's got 3 different carriers, you know that you're always going to have one way into the box, typically, at least one way into the box and one way out. And you can still remote in and check on connectivity. And because it's got that public-facing IP address, it's straightforward to set up your own virtual private network.
Yeah, there is so many different flavors of how you can implement it, but ultimately the technical reason is that we use the best use of everything available, and that's why we technically give you the best chance of success. And then the empirical evidence is that, again, we've deployed in so many different situations, and we know that in all those quote-unquote live event situations, which is, again, can be remote venues, can be urban venues, can be crowded, can be desolate, we've seen it all, and we see consistent pattern in that we are able to deliver enough pretty everywhere to pipe the one stream out. In many places, we can give you more, and you can build more on this. But if you're talking about the nines of reliability, where we can say you can build your business around, is single stream out. If you're able to figure out how to do the multicam routing, encoding, production of a stream locally, then you're golden. Because I see quite commonly today where it's like still industry still figuring out what's the right way to do it. And I see that quite often people just connect a bunch of different cameras and they just assume it's just going to work and they're going to produce it in the cloud.
Right.
And they start popping like 6, 10, 12 feet, like full capacity each. And if you have a fiber, you're fine. It's not something you can reproduce easily everywhere you go.
Right. I think you have to match your intention to your pipe. Match your intention to the narrowest pipe that you have. And if you're going over cellular, that can be a pretty narrow pipe. It's funny, we ran into each other at NAB this past April, and we were having an issue with our solution. I don't want to go into the specifics because it was partially a firmware issue which has been corrected. And I know that the Office Global people were having an issue doing live. And we literally crossed paths at NAB. And I was like, oh, it's really rough. And you were like, oh, everybody seems fine.
Everybody's very happy, yeah.
Yeah.
It's actually like, we had a few customers at NAB.
Yeah.
And few new ones who we picked up because whatever they brought wasn't working.
Mm-hmm.
And we I had a couple of units on me just to show off, and I just sold it on the floor.
Yeah.
Because it just literally takes 30 seconds and we give you better performance than the floor internet consistently everywhere on the show. So like, why would you suffer? Like at this point, it's intentional choice, Peter.
No, that's true. It is true. I like to eat my own dog food, so I like to sample all the dog food out there.
Fair enough.
And it does make me more knowledgeable about this stuff, even if it does frustrate me sometimes. So we've talked about a couple of use case scenarios. I mentioned the point of sale. Mm-hmm. We were talking about streaming. I think it's an interesting idea to kind of break these out into,
very different.
Streaming. That stream has to get out there, especially if you're trying to do low latency streaming. Mm-hmm. You've got to push those bits into the cloud, and it has to get to its destination in order quickly. And there's a couple of different technologies that we could do at the application layer locally, and then using your box takes advantage of the various best case scenarios of the physical layer, thanks to bonding and debonding. There's other applications, and I'm thinking of camera to cloud.
Oh, yes.
Which is important to talk about. Now, that's by design best effort technology. When there's a connection, it uploads, and when there's no connection, it pauses. I think MRNet has a lot to offer to this space. Physically, it's a small box. It fits on a DIT cart. It runs on 12 volts, can be modified to run on a battery. Mm-hmm. And I do think that it just anywhere that it goes, it's going to pick that best signal out to the cloud.
Definitely.
And just, my experience that is a lot of the camera to cloud implementations that I've seen get really cranky when the WAN connection changes. But I think one of the advantages to this box, and to be fair, a lot of the other bonding solutions out there, to the application, it's a stable WAN.
Yes.
So that it's a lot smoother of a process.
Yeah, so this is a side effect, which makes it much easier because, yes, like whatever you connect to it, wherever you are, it's going to be same network, so application layer doesn't need to freak out. And some applications are more adaptable to it, others less, but ultimately it makes everything simpler. But coming back to the camera to cloud as a use case as a whole, so the challenges of camera to cloud is that they are by nature in those locations with compromised infrastructure. Often they're on the go. Often there's just nothing to plug into it. And if they try to use any cellular pieces, it just makes no sense. And the only thing they used to using in those situations is like way more sophisticated encoder solutions, which are going to run 10 to 20 times more expensive. And if you're just doing camera to cloud, it's extremely hard to justify those costs.
Right.
And so we are perfect balance there where we are more expensive than a hotspot, but not by that much. And we're going to give you this reliable access wherever you go. And if it changes, if it's fluctuating, you're going to have your camera to cloud working. And as a result, the benefit for the end outcome is, for example, like sports camera to cloud. What it means is that they have in tier 1 at least, sports, you have the main broadcast, obviously millions spent on it, it's going to be flawless, it's going to work well. And the camera to cloud people are the ones, like photographers going around, shooting some interviews, shooting some nice pictures, and it's all done for the social media engagement, primarily. At least it's primary use case I've seen. And for them, it's important that it is close to real time, because if you have a big moment, you captured it, and you upload half an hour later, you're kind of missing the point.
It's already been shared, and
Exactly. So you have to be upfront. So your network has to work,
Yes.
but you cannot justify spending 20 grand on it. And so how do you balance this out? And that's where we come in. We give you this reliable network. It's going to give you exactly what you need. It's going to upload your data right as soon as you shoot it. It's going to be in the cloud instantaneously. And now it can be done with, and your producers on the back end going to figure out how to distribute it where it needs to go. And so it's reliability, solving what you need, and it's not going to break your budget. So that's kind of like camera to cloud in a nutshell.
I think this is a perfect segue to talk about how people can get this box, what it means in terms of price and the continuing service.
Yeah, we are available direct. We are available through our channel partners.
And Gotham Sound
is one of our treasured channel partners. And we ourselves don't do short-term rentals. That's not what we set up for. But some of our partners do.
We do.
Gotham Sound. So this is an easy way to get a short-term option. And ultimately, the way we sell to the space, what you sign up for is our all pricing is public. And again, I don't know where you're watching it. It may change back then, so I don't want tie you to specific numbers. But the ballpark numbers today is that would be you purchase the hardware, and it comes with the first year of service, and altogether it's going to be around $2,500. And then in a year, there's going to be renewal for another $1,500 for the service piece. Data, the one we procure, which is again highest quality, best seller data on the market across all 3 carriers with 0 effort from you, it's going to be $8 a gig. If you have your own data, you're welcome to put your own SIMs in. You're welcome to put your own WAN in. You're welcome to put your own hotspot in. You can even use your phone hotspot as a source. We don't charge for any of that. We only charge for the data you use with us, and we ourselves make some money on it, but it's not significant by any measure, and it's by intentionally, because we don't want to have diffused priorities like conflict of interest, basically, because our goal is to deliver best possible connectivity for our customers. And if we now building our business model around charging you for data, extra buck, now we have to keep this price up, even though if the underlying price is going to go down, and I hope they will eventually, and that's one of our mission statements, that we're going to drive it down or eventually. And we want to deliver the best quality for our customers, and that's why we have the subscription piece. And that's our core business, and that's what pays our bills, what allows us to grow, what allows us to innovate, what allows us to be a representative of you in front of the infrastructure providers. And so that's why if you switch to your own SIMs, that's why unlike some of the vendors, we say we don't care, do whatever you want. Yep. You don't have to run on our data. If you have a better deal, if you like what you have, you're good. But the caveat is now we cannot guarantee you same SLAs, because now we know that those data are not going to be as reliable as ours. And if you're fine with it, we're fine with it as well. But it's not something we'll be able to control. If your SIM shuts down for whatever reason or it slows down, it's just nothing we can do in this situation.
I think that $8 a gigabyte for cellular data is very reasonable. I mean, we've done all kinds of math on it, considering that it's $8 a gig with no commitment other than the service commitment.
Yes.
Now, I want to talk about the service commitment briefly. $1,500 a year is what it breaks down to. I want to tell a story. Start of the pandemic, a very good musician friend of mine, Ike Riley, was wanting to do some live streams, and I called up a friend of mine, Henry Cohen, who is with CP Communications, and they have their company, Red Hat Streaming, I think it is, or something like that. And I said, hey, can we make a deal? I want to get this musician online. He said, we can make a deal for the equipment, but the network operations center, they charge money. Like, you need a network operations center. And I remember thinking, I don't need a network operations center. I'm telling you, at NAB, I would have given anything to be able to call somebody and say, hey, log into this box and tell me what's going on. That network operations center, which is what that you get for that $1,500 a year, that is priceless when you are a paid professional to deliver a service.
And yeah, as far as the numbers go, like if you look at it, compare us to the regular hotspot, obviously it's much more expensive, and like that's ridiculous. Why do I need it? But if you flip it from the use case perspective, be priced in a way which, if you use it once in a year, most likely already paid for it. And that's the whole point. Like, if you use this unit once a year on your key show, it's practically guaranteed it's going to pay for itself. And the easiest way to introduce it on the pricing side of things, if you ever do trade shows, if you want to get trade show internet, floor drop, the quotes range somewhere between 3 to 20 grand for a show internet.
We know this well. And I would argue that you would provide better service remotely than the local trade show.
Most likely.
Customer service.
I don't want to guarantee it, because some of the people are very, very proficient at what they do.
No. And to be fair, I don't want to knock them.
Yeah, exactly.
But I know that if I call your network operations center for support, I'm going to get somebody knowledgeable right away. That's going to give me very personalized, understanding service. Whereas a trade show, it's best effort. They're servicing a lot of customers. Again, we talked about how streaming is a very specific use case of constant bit rate up. That's not what a lot of these providers care about or set up for. You're not their primary user for that. So it can be very challenging. I want to touch on one last thing before we come to a close, which is, you are not new to computer science and data connectivity. Tell us a little bit about your background.
Well, I've been in technology before we started this for a little over a decade. I'm computer science by trade, and I have some telecom, went to telecom college for my bachelor's, so I have telecom background as well. And as far as computer science goes, I've been software engineer with product oriented, so I've been kind of like, while I'm on the software side, I've always been connecting with the product side of the house, so I would be able to make software for people instead of just software for the sake of software. So I had this translation layer built into my career. And before starting this, I was at Google. Before Google, I was at LinkedIn. Before LinkedIn, I've been in 4 different small companies, typically running some sort of engineering efforts for them. Whereas it's like smaller team doing specific sub-projects, whereas it's like I'm being just responsible for everything. That kind of depends on that small company, but yes.
I love that. You didn't just fall into data connectivity. This has been...
It's actually, it surprised me as well, because while I knew the technology, creating something of my own was kind of inevitable, making it in telecom space, when I was at telecom college, I was convinced that I'm never going to use this. And then I just ended up doing this. So that part is hilarious. But as far as like building technology-oriented company, that was writing on the wall. The question was timing.
Thank you very much, Anton, for sharing all of your knowledge and sitting down with us. Thank you for watching. If you are interested in this product, please email us. If you want to buy it, sales@gothamsound.com, rentals@gothamsound.com. Leave comments and questions in the chat. If you have ideas for videos, info@gothamsound. Subscribe to our YouTube channel. Thank you very much. Thank you, Anton.
Thank you, Peter. It was a pleasure.
Likewise.